first lecture then, we're talking about descriptive statistical techniques. And for many people, I'm aware some of this will be quite familiar, but it's good to start at the beginning and build up the pieces. Okay, so almost always we're going to start being faced with some data. This is just some data in Excel, but it shows the format, where we often have variables in columns. That's our data, maybe variable names along the top there. And then we're going to have individual cases, which might be individuals, organizations, countries, or whatever it is that we're studying, which are our rows. So each row is a case, each column is a variable, and so the cells tell you the value of that variable for that person. And behind the software that we're using, we're usually going to have some data that's sitting in this sort of format. So the first thing we might want to do is get some sense of what typical values in this data are. And we would more formally call this measures of central tendency. We want to get some sense of a typical value, some sense of the middle, and then we might want to get a sense of the range of the values. So how close are people to this typical value? How close are they to the middle? And we call these measures of dispersion. How spread out is the data? So we're going to have a few different measures that tell us something about the typical values, and we're going to have a few different measures that tell us something about the range of the values. But our aim is to get down from a large amount of data, from a lot of numbers, into a smaller number of numbers that tell us something substantive about that bigger set of data. So for our measures of central tendency, there are three primary measures that you'll see most commonly. The mean, first of all, which is what people often are meaning when they talk about the average. The median, which is the middle value, so the value of some data where half of the data points have a bigger value and half of the data points have a smaller value. And the mode, which is the most common value, the actual value that is repeated the most. There are other measures of central tendency that you might come across, which could be appropriate in particular situations, but these three primary measures that are probably fairly familiar are certainly the most commonly used. So the mean, or more popularly the average, is just adding up all the values and dividing by the number of observations. Good thing about it is that it uses all the values of the data, so it is based on all the values, and any set of data will have a unique mean. That there is, if somebody else calculates the mean, they're going to get the same figure. The downside is that it is affected by extreme observations. If you have a lot of people with very similar incomes and one person with a very high income, the mean is going to be skewed. It's going to be pulled towards that high value, which maybe isn't ideal if what you're trying to get at is a typical value. And it's the only measure of central tendency where if you look at all the deviations, so that's the distance from the average to each of the observations, that if you add up all the ones that are above and all the ones that are below, they'll be the same. The net value will be zero. So there's as much distance above as there is below. So it's easy to work out, but it is vulnerable to extreme observations. The median is the middle value after you order them all. So if you're talking about income, you line everybody up in order of what they earn, and you find the person that's standing in the middle of that line. We're not going to try that. Okay. If there's an even set of numbers, then obviously there's not going to be a unique observation in the middle. So you would take the average of the two that are in the middle. Again, each set of data will have a unique median, and the main advantage of it is that it's not affected by extremely large or small values. If you think about that income distribution, even if you have one person with really high income, increasing their income isn't going to move the median, because the middle person will still be in the same place. So that's its So it's particularly valuable in data sets where there are extreme values, but what you're trying to get at is a more typical value. So if you think about this is say a distribution of income. We've got a lot of people in the middle here. We've got a smaller number here, or a smaller number here. In this case, where the distribution is pretty symmetrical, the median and the mean are going to be about the same, and are going to be a pretty good description of the center of that distribution. Okay, there are lots of people earning this much money. There's some above, there's some below, but that's a pretty good measure of a typical value, or of the middle. If you have data that looks more like this, so you've got quite a lot of people here earning a lower wage, and then a small number of people earning really high wages, and so this long tail, then your mean is going to be pulled out here, whereas your median is going to be closer to this peak here. Okay, so the mean is pulled out by these outliers, and the further they are, even if they're small numbers of people, they're going to start pulling this measure to the right. And in this sort of case, we might feel that the mean isn't actually that good a measure of the typical value in this data, and then in fact the median does a better job. Our third measure then is the mode. So that's the observation that appears most frequently. Now, it's not going to work so well in data that's really continuous with lots of values. If we looked at the wage, if we were thinking about income and we looked at the hourly wage that occurs most often, what value do you think we might get? If we had a whole lot of data on people's earnings, which value do you think might occur most often? Any suggestions? The minimum wage. Yeah, absolutely. The wages, even wages that are pretty similar, could have actually different amounts. So which figure is going to be the most common? Well, probably the minimum wage is going to be the actual physical amount that the largest number of people are being paid, even without the minimum wage being the typical wage, just because people who are paid more might be paid amounts that differ by pence, for example. So it's not going to be good where you have data that's continuous, where things that are quite similar are actually just slightly different, and so you can't really count them. But if you have a smaller set of values, then it makes more sense to think about counting the number of them and looking at the one that's the most frequent. So it's more commonly used when you have categorical data and you want to count, let's say you've got data on occupations and you've got 10 categories for occupation. Everybody's in one of those 10 categories. Which category has the most people? Makes sense as being the most common occupation. Even if they're numbered 1 to 10, there's going to be lots of people with the same number. So that's useful, and even when the categories are ordered, that can be a useful measure of the middle. But it's not going to make sense when you have data that's interval or ratio, when you have metric data that has a high level of precision. It could make sense with that sort of data where there isn't that high, where there isn't that big a range of values, or there isn't that high precision. So, for example, if you were measuring temperatures and you measured them in centigrade without any decimal places, so it's just 17 degrees or 18 degrees or 19 degrees, then the most common temperature, might make sense. There's a small enough number of values that might make sense. But most often you're going to use the mode with categorical data. Okay. So when you're using these techniques, you're thinking about just a single variable from your variable by case matrix. That's the spreadsheet, the data that I showed at the start. If it's metric, you're going to use summary statistics to summarize its spread of values, the mean, and we'll talk about dispersion in a moment. If it's categorical, then probably you'll show a frequency table to show how many of each category there are, how frequent are different occupations, for example.